In this lesson 1-1, we will be working with variables and expressions. At the top of your notes, what I'd like you to write is the title, Variables and Expressions, and I also want you to write the I can write algebraic expressions, and the date. So at the top, before you start your notes, you always have the date. You have exactly what you see here on the first slide, 1-1, variables and expressions, and I can write algebraic expressions. So by the end of the video and the work time in class, you should be able to state the I cans. So you should be able to say, I can write algebraic expressions by the end of the lesson. We are going to start with some vocabulary that we're going to write in our notes. Quantity is the first term. A quantity is anything that you can measure or count. So just think of things that you are able to measure or count, and those things might be constant. They may change. A variable. I know you've heard of variable before. It's a symbol that represents the value of a variable quantity. So it represents some value. We use our letters for variables. A through Z, a lot of times we see X and Y, and you'll see X and Y most often in the algebra class, but any lowercase letter can work for a variable. And it's just a symbol here that's representing the value of something. And that something might be something you know, it might be something you don't quite know, but you're going to look for. Today we're going to work with algebraic expressions, and it's an expression because it's a math phrase without an equal sign, and it includes variables because it's an algebraic expression. Algebra, we have symbols, so it's a mathematical phrase that includes one or more variables. So it's a phrase, it doesn't have an equal sign. You could see any operation, you could see addition, subtraction, multiplication, division, you might see parentheses, square roots, exponents, but you won't see an equal sign. A numerical expression is when you have the same sort of thing in terms of what I was just saying for an algebraic expression, just no variables. You would just have numbers involved in the expression or in the phrase. It's a mathematical phrase involving numbers and operation symbols, but no variables. And so what we're going to do is look at algebraic expressions a little bit more, and we're going to be answering the question, what is an algebraic expression for each word phrase? 25 more than a number n. So we look at this phrase and we see more than, and we should know what more than is. More than is giving us an addition operation symbol. 25 more than a number n. So we have 25 that we're dealing with in n. So if I have n, which is some number, we don't know that n is representing a value, and we're looking at 25 more than that, we're adding the 25. So n plus 25 would be an algebraic expression. So I'm going to circle that. That is our answer. We could also have 25 plus n. It's commutative. The order doesn't matter. 74 less than a number n. So less than, we know we need to work with subtraction, and it's 74 less than a number n. And it's very important that you put it in this order, and you can kind of think about it and replace n with some value and think to yourself, okay, what is 74 less than 100? And so we think about that and we get 26. And so we plug in 100 here. 100 minus 74 gives us that 26. See, if we had those flipped around and it said 74 minus n, so 74 minus 100, we're dealing with negative, and that shouldn't be the case. And so we know we did the order correctly. So you can always plug in some value into your variable to see if it works and if it makes sense to you. 5 times the number n. So we're dealing with times, product, multiplication. We have 5 and we have n, and we're multiplying them, and that's it. Now, this is one way to represent a product where you're multiplying, or times in this problem here. You could also use parentheses to show that product. You could also use a dot to show the product. Please don't use an X for multiplication since we're working so much with variables, especially in the algebra class. I would prefer the first one. Put the coefficient, which is the 5, something we'll talk about, put the 5 in front. Put the variable second. The quotient, so key word here, we're going to underline quotient, the quotient of a number n and 7. So we're looking at n and 7, the quotient of n and 7. When it's asking for the quotient of something, that first number is going to be your numerator, which was right here. The second number is going to be your denominator. Quotient, you're dividing, same as a fraction. You could also write it n divided by 7 like this. I would prefer the rational number form. Quick review. Number 1, commutative. You could also have 25 plus n, just remember that. But number 2, with the less than, order does matter. Number 3, 4 times multiplication. Order matters in that in terms of, I would like you to put the 5 in front of the n, but really it's commutative. You can do n times 5. It's just how we write it. And with the quotient, that first number is the numerator. What is an algebraic expression for each word phrase? 4 more than twice a number x. We look at the key words, more than and twice a number x. So we're dealing with 4 more than twice a number x. And there we go. We could also have 2x plus 4. I'm going to circle our answer. 7 less than, so we have 7 here, less than the quotient of 8 and a number x. So this would be 7 less than the quotient 8 and the number x. Order mattered. I had to put the 7 in there in the second term here. It's 7 less than the quotient, which we're dividing here. 8 goes on the top because remember that was first, that's your numerator. Oh, and I kind of went into this next problem here. It says the product of 9, so product, and we have 9 under there, and the sum of a number in x. So the product of 9 and, this is key, it's saying the product, you're multiplying 9, so we got 9, and the sum, which we know we're adding, sum, let's see, it was sum of a number x and 2. So if we had x and 2, the sum of that, we have to multiply that by the n, or I'm sorry, by the 9. Now here we have to put parentheses because we're multiplying the 9 to the whole total, x plus 2. So it's important you have the parentheses there because if you just wrote 9x plus 2, you're not multiplying that 9 to the 2 here. So that is not going to work for writing this algebraic expression. You have to put the parentheses there since you're multiplying the whole sum by 9. Let's see here. What word phrase can you use to represent the algebraic expression for x? And so that would be a product. So I would say the product. Just ignore that, what just popped up here on the screen. I might just come up there together here. Oh, there we go. The product of 4, well, I guess it just wants to show up, and that's fine. So the product of 4 and a number x. And so that would be a word phrase. We're dealing with a word phrase here. And our last problem here for our notes. There we go. The table shows how the cost of renting a scooter depends on how long the scooter is rented. What is a rule for the total cost? Give the rule in words and as an algebraic expression. So you can see over the course of 5 hours, the cost is going up. And so what we want to do is we want to say, okay, how much is this going up by? every hour as we go up per hour, and we can see from $17.50 to $25, it's going up at $7.50, so $7.50. And it's consistent from 25 to 32.50, it went up $7.50. And it keeps going up $7.50. So every hour you're adding $7.50. Now if we went back an hour at 0 hours, that would be a cost of $10 when you're going back. What is that $10? That's just like you go up to the shed where you want to rent a scooter or some store or something. You go up to the counter and you say, I would like to rent a scooter. And they say, okay, it costs $10. Just $10 initially to rent the scooter. So you're paying that initial $10 cost plus an additional $7.50 per hour. And that would be our algebraic expression that would represent this problem. So it's asking us what is a rule for the total cost. Give the rule in words and as an algebraic expression. So here's our algebraic expression. And then in words, I would say multiply the number of hours by 7.5 or 7.50 and add $10. And that would be in words. Can you say I can write algebraic expressions? At this point in your notes, I want you to summarize the notes and reflect on the notes. So please summarize today's lesson in 2 to 3 sentences. So go back and look at the key things we talked about. Reflect your understanding of the concepts covered in this lesson. Do you have any questions? Write those down. What are they? Be prepared to ask questions during class time. Remember, I'm here to help you.